Bonjour, welcome to Wahsa Distance Education Center's radio Zoom classes. This is MBF3C, grade 11 college math, and I am the teacher Bronwyn Slade. If you'd like to participate live today, you can call the Wahsa studio at 1-800-465-7144 or 737-4017. You can listen on the radio at 91.9 FM and also on the television at Bell Express View channel 972. You're always welcome to join me live through the Zoom link, which is available both from me, your teacher, and also your DEC. Our classes are scheduled from 10 until 11 on Monday through Thursday, and we are in our 4th out of our 9-week courses. At this point, what you should be submitting work, as we are about almost halfway through the course content. So a reminder that the support questions, the ones with a little pencil icon, are not for marking. You decide which ones and how many to do. If you understand a concept, it is totally okay to skip questions and to not do them all just because they're all there. You understand what is best for you, and you can make that judgment for yourself. The answers are in the back of your booklet, so I strongly encourage you to do some of the practice problems at least and to check your work to make sure that you're on the right track. The key questions, the ones with little key icon, are the marked questions. So these, you need to do all of them. You need to show all of your work, your steps, and your thinking. This way, I can know what it is that you know, and if you are struggling with something, it gives me more information so that I can support you with it. So how do you submit your work for marking? There's 3 methods. The first is to scan your work and send it electronically. You can use a device. If you have an Apple device, you can use the Notes app, and that has a scan function, and the Android devices come with a Google Drive app that has a scan function. These are fairly straightforward point-and-click scanning, but if you do need support, on my YouTube channel, there are tech tutorials that walk you through how to use each of these apps. Then you can send it to me through email to studentwork@nnec.on.ca and CC it to bronwyn.slate@nnec.on.ca, or you can also send it to me through Facebook Messenger, where my name is B. Slate Wahsa. The second method is to drop it off in Sioux Lookout. We have an outdoor mailbox at 74 Front Street. We are the bright red building next to the post office, and we have a small white mailbox next to our side entrance. The third method is to hand it into your DEC. Your DEC can either send your work through the Express or fax it to 807-737-1732 or toll-free fax to 1-800-463-7852. Students can also send in their work through fax if that's something that works best for you. Though just give us a heads up that it's coming, as sometimes things can get lost in the shuffle. If you'd like to connect with me through social media, both my Facebook and my YouTube channel are under the name B. Slate Wahsa. You can friend me on Facebook and subscribe to my YouTube channel, and then you'll get notifications every time I upload one of our YouTube lessons. All of our radio Zoom classes are recorded, and I upload them shortly after broadcasting to YouTube. So it's a really easy place to find everything that we've done. So you can go and review things if need be. Also, there are short videos that explain common errors and confusing concepts. So it's a good place to go if you are struggling with something. Just instead of doing a general online search, this is a good place to start. Math is an extremely visual subject, so I strongly encourage you to access the videos, either joining me live through Zoom so you get the full experience, or watching the YouTube replays. Both are really good options. If neither of those work for you, then let me know, and I'm happy to send you a copy of the videos so you still get the full experience. If you have any questions or concerns, please reach out and connect with me. My email address is bronwyn.slate@nnec.on.ca. My Facebook is B. Slate Wahsa. You can call me at 807-737-1488, extension 2209, or toll free 1-800-667-3703. My office hours are Monday through Friday, 8 a.m. to 2 p.m., though I teach from 9 until 11 on Monday through Thursday, so that is not a good time to try to get a hold of me. Today's lesson is lesson number 9, and we're looking at loans and RRSPs. Our learning goals are that at the end of this lesson, you will be able to calculate the cost of borrowing money to buy an expensive item, and you will also understand the advantages of early deposits to long-term savings plans. You know you've met learning goals because you can calculate how much money it costs you to borrow money, and you can show with calculations the advantages of depositing money early into a long-term savings account. When will you use this in real life? Well, we're strengthening our ability to think critically. As we've said before, money is really a vital part of our society. So understanding it is going to set you up for the most success financially and hopefully help you be financially stable. So with this course, we are developing our ability to think critically and make decisions and justify those decisions so that we know what is best for ourselves, because there's not one thing that works for every single person. All of our situations are different. So being able to think about our own situations and make decisions based on our own needs is super, super important. But first, let's activate our brain with some mental math. I don't believe in mad math minutes. I think they cause stress and anxiety and do not actually build math skills. So instead, we work on developing strategies that you can use in various situations that are based on your comfort and knowledge of numbers. Our question today is 685 plus 947, and we are using the strategy of breaking up by place value. So often when we're learning to add, we're told to just stack our numbers up and add them from right to left and just think of the numbers independently. But what we're going to do is we're going to expand our numbers and think about them in their own place value, to think about logically what's going on. So 685 is 600 plus 80 plus 5. And 947 is 900 plus 40 plus 7. As long as we're having it with our place value, we don't have to, we can add up in a way that makes sense to us, that feels comfortable. So like looking at these, I can say, well, I know that 80 plus 40 is 120. Okay, great. 600 plus 900, well, 900 is 1 away from 1,000. So if I take 100 away from 600 and compensate it to this to make it 1,000, then I have 500 left. So I have 1,500. Okay. And then 5 plus 7, well, this is like a near doubles, right? If I steal 1 from the 7 and add it to the 5, then I have 6 plus 6. So that's 12. So then I can add them and I say, okay, well, 1,500 plus 120 is going to be 1,600. And then, but I have 20 plus 12 is going to be 32. So 1,632 is what those add up to. So this is one that can be really, for some folks, can be easy to visualize in their head. So it might not be easy to visualize for everyone, but for some people, it can be straightforward to visualize in your head, which can be really easy to, that can be a way to break it up, your numbers, in a way that adding them can be helpful. All right, mine's on. What prior learning do we need to know for today's lesson? I just want to go over some financial vocabulary to make sure that we are all talking about the same thing. So, loan is when you borrow money from a person or a business. So you are getting money that you didn't have before, and then you pay money, which is called interest, to them for letting you borrow their money. That's how a loan works. An investment is when you lend money to someone, to a person or a business, and they give you money, again, called interest, to you for letting them borrow money. So they're the opposites of each other, depending on if you are borrowing or if you are lending money, and the interest is paying whoever initially had the money or lending it. We also want to remember about compounding periods. We talked about this before, but we just want to go over it again. So annually means that it's 1, semi-annually is 2, quarterly is 4, monthly is 12. Those are the words that mean those numbers. Semi-monthly is something that's new, and this is twice a month. So it happens 24 times a year. Weekly is 52 times a year, but then biweekly is every 2 weeks, and that happens 26 times a year. There's 26 2-week chunks in the year. So these ones can be confusing because they happen similarly, semi-monthly and biweekly, but they are different. There are 26 biweekly periods in a year, and there's only 24 semi-monthly periods in a year. And then daily is 365. Remember, we always do 365. We don't care about leap years for our purposes. All right, so what new concepts are we learning today? First, we're going to look at loans. This is on page 21 of your IL booklet. So reminder, when you take out a loan, you must repay the loan plus any interest that has been charged. So with a loan, you have to pay back all the money that you borrowed, plus you have to pay back interest, so that fee, that money that you're paying because someone was nice enough to lend you money. So interest is the cost of borrowing the money. Most commonly, loan payments are calculated and given a regular payment per month or per period, set time period, but it's set so that when you start borrowing the loan, part of the conversation is that, yes, this is how much money you're borrowing, but also this is how often you're going to be paying it back and what your payments are going to be, which will include the interest that you're paying. You'll pay a little bit of interest. You'll pay interest every time you make a payment. So assuming that it's monthly, it isn't always monthly, but assuming that it's monthly, the payment covers paying some of the principal and some of the interest. So then for loan payments, we use what is called the present value of an annuity formula. So this, you don't need to remember what the name of the formula is, but we're going to look at a loan payment. This is the formula that we're going to be using. So this is a new term that you might not be familiar with. Annuity is a fixed sum of money paid at a regular interval. So this is you decide what your payment is going to be, and you're going to pay it at this certain time, every 2 weeks, every month, weekly, whatever this agreement is. All right, so let's look at what this formula is. Now, if you have a booklet that is prior to my revision in 2021, it is very poorly typed. It is the formatting on it. It's completely confusing and just got bumped around and shifted, and it's bad. It's really, really bad. So if you have that booklet and you would like to connect with me so I can give you an updated version of that, or you can just use what is on the screen here, that's fine. But just recognize that I do realize that it's not okay within that booklet if you had it before 2021. So the formula is PV, so present value, is equal to R times 1, take away, then open a bracket, 1 plus I, close a bracket, and that part that's in brackets to the exponent negative n, and then all of that is divided by I. These formulas are a little bit complicated. I am not going to make you memorize them. You need to understand what the parts are and when to use them. Okay, so what are all these variables? So PV is the amount that must be invested now, so dollars, or how much it is worth now, the present value. R is the regular payment. I is your interest rate, expressed as a decimal per compounding period. So this is the same as what we've been doing before. So your interest rate as a decimal divided by the number of interest periods in 1 year. This one, there's already so much going on in this formula that it doesn't make sense to break it up more. You just need to remember that you have to do both the interest rate divided by the compounding periods. And then N is the number of payments made. So again, this is your number of payments per year times the number of years. So how many payments there are in total. It's really, really important to not forget BEDMAS. I've had students who just say, well, it's one, take away one, so I just need to subtract those. Those aren't important. If they weren't important, we wouldn't put them in. Mathematicians are lazy. We do not do extra things just for fun. I know it might seem to make things confusing just for fun, but we don't. We don't want to do extra work that isn't relevant. You need to do inside the brackets first. You need to do this 1 plus I to the exponent negative n. You need to do that first, and then you're taking that away from 1. So this is super, super important that you need to do BEDMAS. You have to do the order of operations. If you just do 1, take away 1 and ignore that, you are going to get the wrong answer. It is not going to be correct. Okay, super important. All right, so let's look at an example about how we actually use this formula. So a set of winter tires can be purchased for no money down and 12 easy payments of $89.55. This is something that we often hear in advertisements, right? Interest is compounded monthly at 15.7% per year. How much do I end up paying for the tires in total? So because this question says payments, we know that this is not a simple interest question. It didn't say simple interest. It is not just a compounding question, because with the compound interest questions, we only have one investment or one loan borrowing, right? We're not making payments. We don't change it. We just have that one principal amount at the beginning. And then we don't have to worry, we're not doing anything other with payments. So once the question says payments, then we need to start looking at these new formulas that we're looking at today. So that's super key to note. That word means that we need to be looking at these formulas. So because it's a payment question, we know that we're using the PV equals R times 1, take away 1 plus I to the exponent negative n, all divided by I. And we need to look at what variables we know and what we're looking for. So here it says 12 easy payments. So our number of payments is 12. This one, we don't need to do it. It isn't that it doesn't say how many years. It just tells us the number of payments. So we have to remember that n is equal to the number of total payments. We might need to figure out if we need to multiply it by something because it tells us how many payments per year and how many years. But in this case, we just tells us 12 payments. So that's the number of payments. The payment is $89.55. So that's our R. Our regular payment is $89.55. And then our I is our interest. So it's our interest rate is 15.7%. So 0.157 divided by the number of compounding periods. It's compounded monthly. So we divide it by 12. Then how much do you end up paying? That is our present value. That's how much we are going to end up figure out how much we pay in total. So then we put all of those variables into our formula. And as you can see, it can get tricky. So you want to give yourself enough room. If you're trying to squeeze this into one line, if you're writing on line paper, it's going to be tricky. You want to give yourself space. Personally, I like writing on blank pages so that I have as much room as I want, but you do whatever works best for you. But you can see this is why writing down all your variables is really important so that you can then, it helps you keep yourself organized because it can get really complicated. So our formula is PV equals 89.55, then open a bracket, 1 takeaway, then open another bracket, 1 plus 0.157 divided by 12, close a bracket, to the exponent negative 12, close a bracket, divided by 0.157 divided by 12. So you can do some of these steps in between using your calculator. You can put this all onto in Desmos or into your own calculator and do it all at once. You decide. Remember, if you are going to do some of the division and round it off to 4 or 5 decimal places to get more of an exact number. Personally, I like to put it all into my calculator. There's a Desmos scientific calculator. We've used the graphing calculator a bit, but remember the Desmos scientific calculator, which I use all the time, has an online base, like an online platform, but also has a free app that you can download both from the Apple Store and the Play Store. So check those out. There's links in the show notes, or I can send you, if you can't find them, let me know. Sometimes they can be tricky to find, but let me know and I can help you find it. So once we do that calculation, we get PV equals $988.53. So what does that even mean? I'm like, at this point, I'm like, what were we even finding? So go back to the question and says, so the question asks, how much do I end up paying in total for the tires? So therefore I end up paying $988.53 for a set of winter tires. So when you start off and you're like, oh, $89.55, that doesn't seem like very much, but 12 payments of that plus interest is a lot of more money. So just something to be aware of. Okay, so that's finding how much money you pay in total, but also finding the payment amount can be useful. How much, if you know how much you're going to be borrowing, you want to figure out how much that means you have to pay on a regular basis. So we start with the same formula, but we then rearrange it. So we started with PV equals R times 1 minus 1 plus I to the exponent negative n divided by I. So now we're going to do some algebra to rearrange that to solve for R, your payment amount. So we were dividing by I, so we're going to multiply both sides by I to cancel the I off. So we have PVI is equal to R times 1, take away 1 plus I to the exponent negative n. So we're going to divide by 1 minus 1 plus I to the exponent negative n. Again, this is why being able to see the videos is really important, so you can see what I'm doing, because listening to it is really, really hard to understand the subtleties. So those cancel out, and so then we're left with R equal to PV times I divided by 1 minus 1 plus I to the exponent negative n. Again, you do not need to have this memorized. You need to be able to apply it. You need to be able to use it. You do not need to have it memorized. I don't have this one memorized. I have to look these ones up to make sure I'm using the right one. Okay, so let's look at an example. So when you're finding the payment, the R, so we're going to calculate the monthly payment of a $15,000 loan at an 8% interest rate, compounded monthly over 5 years. So again, this question says calculate the monthly payment. Because we know that we're making a monthly payment, we know that we have to use these payment formulas. So we're going to just use the R equals PVI divided by 1 minus 1 plus I to the exponent negative n, because we know that we're trying to find the monthly payment. So that's why we're going to pick that. That's what we're looking for, the R. We have a present value. Our loan is $15,000. Our interest rate is 8% compounded monthly, so 0.08 divided by 12. And our N, we have it for 5 years, but again, it's compounded monthly. So remember, this time we don't know how many payments we're going to have to make unless we do 5 years times 12 payments, because we know that we're making monthly payments. Then put that into a formula. And we have R equals 15,000 times 0.08 divided by 12, all divided by 1, take away 1 plus 0.08 divided by 12, all to the exponent negative 60. So again, you can use that on your scientific calculator and you can do part using Desmos, or you can put it all in and you get that your payment is equal to $304.17. So again, it's a really good idea to check to make sure that you have actually answered the question. So therefore the monthly payment would need to be $304.17. Does that make sense? That seems like a reasonable payment amount. So yep, that sounds good. So then from there, we can also have to calculate. So once we know what our payment is, they might ask us to calculate the total interest paid over the term of the loan. So we know that we borrowed $15,000, but how much do we end up having to pay back in total? Even though you're paying it in small chunks, monthly chunks, how much do you end up paying back in total? So to do this, we need to think about how many payments we make and how much those payments are to figure out how much we pay in total. So the interest is equal to the total of the payments, take away your present value, how much you borrowed. So this, you could, if you wanted to do a formula, you could say that I equals R times N, take away PV. You can also just think about it logically, and that's fine. So your I is equal to, for this question, $304.17 times 60, because there were 60 payments, right? 5 years of 12 of monthly payments, so 60 payments, and then take away the 15,000 that you actually borrowed. So that is $18,250.20, take away 15,000. So you pay $3,250.20 in interest for borrowing that $15,000 and paying it back over 5 years. So this is why it's important to understand, because you can end up paying a lot of interest. So the total interest paid is $3,250.20. All right, so that is support, or sorry, that is loans. So that you can add the support questions on page 23, 1 through 5. Now let's look at RRSPs. This is on page 23 of your IL booklet. Let's understand what an RRSP is. So it stands for Registered Retirement Savings Plan. So it's a saving plan for people who earn income, and you can contribute funds, and interest earned are not taxed until the money is withdrawn. So this is why they're awfully encouraged, because you can lower your tax bracket. You can think, we didn't do that in this class, sorry. You can pay less taxes when you are making an income and you have a higher income. And then you pay taxes on these when you take the money out. So once you retire, you set up a system where you can withdraw regular equal amounts from your RRSP. So you take money, it's like a savings account that has earned you interest over a period of time. And now once you retire, you can take money out of it. So again, we're going to look at the formulas that calculate these. But if you have a booklet before I was able to update them in 2021, the formula again is really poorly written and really confusing. So either ask me for a updated copy or just use what I have here on the screen. So for this one, if you plan on contribute to an RSP, you're going to use what's called the annuity formula. And this formula looks very similar to the loans formula that we just used, but it is different. So here we have A is equal to R times 1 plus I to the exponent n, take away 1, all divided by I. Or if you're calculating for the payment, we have R equals A times I divided by 1 plus I to the exponent n, take away 1. So they are very similar, but the details make it different. So it's really important to be paying attention and knowing which one to use when. So our variables stand for the same thing. So here A is the amount of the annuity. So how much you want to have once you're done paying and contributing into this payment or into this plan. R is still your regular payment. I is your interest rate as a decimal divided by the number of interest periods in 1 year. N is the number of contributions made. So the number of contributions per year times the number of years. That's all the same. Now it's key and important again to look where you're subtracting one, where your subtraction is, and that your exponent in this one is positive, it is not negative. So again, super, super important to be paying attention to these little details. These little details make a huge difference. Also, do not forget BEDMAs. You have to do the order of operations. You can't just do one takeaway one and ignore that. That doesn't work. You have to do the inside the brackets first, then your exponents, then your subtraction. You have to do follow order of operations, or else it doesn't make any sense and it will not work for you. So please do that. It is hard, but pay attention to that. All right, so let's look at an example so that we can understand what it is that we're talking about. So how much is an RSP worth once you're retiring? So Jay began making monthly contributions to his RSP at the age of 31. His average monthly contribution starting 1 month after his 31st birthday was $200, and his RSP earned interest at an average rate of 6.8% compounded monthly. This changes, your interest rate is going to change as the market changes, but for our sake, we're going to just use one interest rate to keep things simple. As simple as we can. All right, Jay stopped making contributions when he retired at the age of 65 and started to withdraw a pension from his RRSP. So part A, determine the amount of Jay's RRSP on his 65th birthday. If he's contributing $200 every month and earning interest on it, how much money does he have after 65? So here we look again to figure out which formula we're going to use. We look and we say, okay, so we're making monthly contributions to his RRSP. That means that we have those monthly payments that we're making to an RRSP. That's how we know that this is the formula that we need to use. So we're trying to find how much, we know how much the payments are going to be. So we're trying to find the total amount. So we use the A equals R times 1 plus I to the exponent N minus 1, all divided by I. So we look through the question to figure out what we know and what we don't know. R is our regular payment. It's $200. We know that. Okay. I is our interest rate, 6.8% compounded monthly. So 0.068 divided by 12. Okay. And N is our total number of years times our compound periods. So it's times 12. Our total number of years is 65, take away 31. So 34 times 12 is 408. So he makes 408 payments in total. And now we say, okay, we're determining the amount of the RSP. So that is our A, what we're trying to find, if that makes sense. So now we put it again into our formula. And we have A equals 200 times 1 plus 0.068 divided by 12 to the exponent. And here you can put 34 times 12, or you can put 408, whatever works for you. And then all of that minus 1. And then all of that divided by 0.068 divided by 12. Again, this is super easy to make mistakes on, and using calculator Desmos where you can see everything that you've put in can be really, really useful. So then you can do parts and round it off if that works best for you. And we find that we have so your final amount is $318,000, $668.14. If you do this one where you just put all of the calculation and you don't round up anything into your calculator, you'll get this first number. If you do the division and the addition and round it off, and you round it off to here like I did 5 decimal places, and then you calculate this, you get this second number that I have, which is $318,959.51. So rounding your numbers does have a big impact. So here, even though we did 5 decimal places, which seems like a lot, it's still another $300 difference between the two numbers. So that is just something to be aware of when I talk about how rounding errors make a big difference. I recognize that you might need to do it because of your calculator, because you keep information organized. It makes sense. I try to be aware of that when I'm marking and make sure that this is why writing down all of your work and giving your steps helps me so much, so that I can see, is it a rounding thing? And that makes sense to me. Okay, I'll give you full marks. If you just give me a number and I don't know where that number came from, it's hard for me to give you any marks because I don't know where the number came from. So the more information you can give me helps both you to keep track of what you're doing and me understanding what you're doing. So therefore, on Jay's 65th birthday, his RSP would be worth $318,000, $668.14. So making that $200 payment every month for those 34 years ends up making so that Jay has this big, huge savings at the end. So if you want to determine your monthly pension amount, so then you use the present value of the unity formula. So again, poorly typed in your book, but this is the same as so if you know how much your RSP is, like we just figured out, and you want to figure out how much your payments can be, so how much you're going to get every month, because you get to choose, it makes more sense to, instead of taking all of that $318,000 and just have that sitting in your bank account. It makes sense to continue to invest that so it continues to grow while you use little bits out of it to live. So again, we're going to use that same formula that we used for loans, because now this time it's like they have the money and you're paying yourself. But it's still super important to not forget Desmos. I'm reiterating that this time because it's super important. Okay, so let's try that in a situation. So we're going to look at the example of when you're finding the monthly amount an RSP will pay. So again, you could take that whole amount and just have all that amount of money in your own bank account, underneath your pillow, whatever, and spend it. Or what most you folks do is we reinvest that money from your RSP so that you can get a monthly income, but it also still keeps growing, because now you have a whole bunch of money that is a big investment. So Jay decides to reinvest the total amount of his RSP to provide annuity for his monthly income during his retirement. So he's getting a monthly payment because he doesn't work anymore and gets that monthly payment or whatever from his employer, but he gets that from his investment. So suppose Jay was able to obtain the same average interest rate and chose a 20-year term for his annuity. So we're just going to stick with the same interest rate. And the term is Jay saying, okay, I want this money to last me until I'm 85. So I think that I'm going to live until I'm 85, and having this money for this long is what I want to do. For 20 years, I want this money to last me for 20 years. So what monthly pension could he withdraw for the next 20 years? So the monthly pension is the monthly payment that he's going to be getting because he doesn't have a paycheck anymore. And what's that going to be for him for those 20 years? So again, because this is an RSP and we're looking for the monthly income, we know that we have the RSP amount and we're getting that monthly income, that monthly payment to us. So we know which formula, this is how we figure out what formula to use. So we're looking for the payment. So we're going to use the PV times I divided by 1 minus 1 plus I to the exponent negative n. So our total amount is that PV is $318,668.14. Our I is the same interest, right? So that's 0.068 divided by 12. Our number of years, our number of payments is 20 years times 12. So 240 payments is what we're trying to divide this up into to make sure we have enough money for those 20 years. And we're looking for the monthly pension. We're looking for how much the payments are going to be. So that's our R we're looking for. So we put our numbers into our formula. So R equals $318,668.14 times 0.068 divided by 12. All divided by 1, take away 1 plus 0.068 divided by 12 to the exponent negative 240. Again, put that all into your calculator or do the steps and round off. So you end up getting a monthly payment of $2,432.52. Or if you use the rounded numbers, then you get $2,435.50. So this is a monthly pension. So the monthly amount is what we calculated, was what we figured out. If you wanted to buy a weekly pension, then you would have to take that into account, that your number of payments would be twice the amount. So that's going to have an impact. Or no, your monthly, you would do 20 times 26 to figure out the number of payments. And that would change everything. So therefore, Jay would receive a monthly pension of $2,432.52. So after investing all of that money, he invested $200 every month for those 34 years. Now he's getting back $2,432.52 every month, which now he's going to have to live on because he doesn't have any other, assuming he doesn't have another income. So you can do the support questions on page 26, questions 6 and 7. All right, let's do a little more practice. And most importantly, we're going to try to figure out how you know which formula to use, because now we have a whole bunch of formulas. So this is the key thing. I would screenshot this slide on the next slide, or write it down, take a picture, whatever works for you. to help you figure out which formula you're going to use, because we now have all of these different interest formulas and it's really confusing to figure out which one is the right one depending on your situation. So if the question includes, like if it says in it, one total amount that's invested or borrowed and it's at simple interest, then we use the I equals PRT formula. So one total amount, simple interest, I equals PRT. If we have one total amount that's invested or borrowed with compound interest, we use A equals P times 1 plus R divided by N to the exponent NT. So you have one total, one thing used depending on the simple interest or compound interest. Okay. So now if you have a loan with payments, it might say it's compounded, it might not, but you are having a loan and you're making payments on that loan. So you're not just paying it all off at the end, you're paying it back in chunks and you're looking for the total amount that you're going to end up paying. That's the PV equals R times 1 take away 1 plus I to the exponent negative N divided by I. If you have a loan with payments, again, might say compounded, might not, and you're looking for the payment amount, so you know how much the loan's going to be and you're trying to figure out how much payment you're going to end up having to pay. That's the R equals PV times I divided by 1 minus 1 plus I to the exponent negative N. Okay. So then if you're contributing to an RRSP and you're looking for the final amount, so you know how much you're paying for every certain period of time, and you're trying to figure out how much you're going to have in total at the end, then you're going to use A equals R times 1 plus I to the exponent N minus 1 all divided by I. Or if you're contributing to an RRSP and you're looking for the payment amount, so how much you need to pay in order to have this much money, you're going to do R equals A times I divided by 1 plus I to the exponent N take away 1. Then if you're looking for how much you're going to receive in a monthly pension or different frequency of pension, but you're looking for the pension from an RSP and you're looking for the starting amount. So how much money you're going to need to have in order to get this much every month. You're going to use that loan payment again. So the PV equals R times 1 minus 1 plus I to the exponent negative N divided by I. Or if you are receiving a monthly pension from the RSP and you're looking for the payment amount, you know how much you have, and you're trying to figure out how much you get each month, you're going to use the payment one of the loan again. So R equals PV times I divided by 1 minus 1 plus I to the exponent negative N. Again, this is why these two screens are really, really useful, because they help you figure out what it is that you're doing and which formula to use. Also, remember, you do not need to memorize these. If you need them for an assessment, either you can look it up because you're just doing your handing in your key questions, or when you're culminating your exam, at that point, I will give you the formulas that you need. You might need to figure out which one you need to use, but you don't have to remember the actual formula. You just need to remember which one means what. So that's still tricky, but you don't need to memorize the actual formula. Save your brain space for something else. Okay, so let's do a practice question to see if we can figure out which one we need to use. So number 1, Seeley recently graduated from college and owes $16,000 on a student loan that he must begin to repay. Payments are to be made at the end of each month for the next 2.5 years. Interest is calculated at 9% per year compounded monthly. Determine the amount of each payment. Okay, so we know that he's making payments, right? So he's making payments on a loan. So that tells us which formula we need to use. Did I write it down? I did, because I, again, don't have it memorized. So we know that he's making payments on a real loan. So that's, we're going to use the R equals PV times I divided by 1 minus 1 plus I all to the exponent negative N. Okay, so then we can figure out what our variables are, what we know. So we know that his present value, so the amount that he owes, is $16,000. We know the interest rate is 9% per year compounded monthly. So 0.09 divided by 12. And we know that he's paying it back for 2.5 years monthly payments. So 2.5 times 12. All right, so to figure out the amount of the payment, we're going to use the formula. Now, because I have it written down over there, I am just going to write out my numbers instead of rewriting the formula that I already have on the screen. So 16,000 times I, which is 0.09 divided by 12, all divided by 1 minus 1 plus I, which is 0.09 divided by 12, the exponent negative, and then 2.5 times 12. All right, and you know, I like to put it all into my Desmos calculator, so I'm going to just do that. So 16,000 times 0.09 divided by 12. And then with the Desmos, what you need to do is you need to, in order to divide all of that, you need to highlight it, and then you can do the division in the bottom. It sometimes takes a little bit of practice to figure out what Desmos wants you to do. The exponent negative 2.5 times 12. Okay, so we get $597.57. So that's how much Sealy's going to have to make in for a monthly payment for those 2.5 years to pay back that amount plus the interest. So then to calculate the total amount needed to repay the loan, so how much got paid in total. So that was, each payment was $597.57 times 2.5 years times 12, right? Because there are 12 payments per year. So again, on our calculator, we are going to multiply that by time we actually paid it. Make sure we get a decimal. So you end up, Celia ends up paying $17,927.12. So how much interest did he pay in total? So that's going to be $17,927.12 is how much he paid. Oops, take away the loan, which was $16,000, which means he ends up paying $1,927.12 in interest. Okay. All right, so that's all the time we have today for practice problems, but there's lots of different practice you can do. Let me know if you need help. Let's quickly consolidate what we learned today because we've learned a lot. So loans, remember, are when you borrowed money that is paid back through equal payments over a set period of time, including the interest. The payments are calculated according to how much we want to pay we want the borrow amount, or how much we can borrow is calculated according to the payment we can afford. So that's a little bit different. RRSPs are saving plans for people who earn an income and they pay you back regular payments once you retire. The earlier you invest, the more you earn in the long run. You can do some comparison questions to see how that works. So success criteria, hopefully one, you can calculate how much it costs you to borrow money. And you can show with calculations the advantages of depositing money early into a long-term savings account. If you have any questions or concerns, please reach out and connect with me. This stuff is confusing. This is fairly math heavy and calculation heavy. So please reach out if you need some support. Give me a call at 807-737-1488, extension 2209, or toll free 1-800-667-3703. Send me an email at bronwyn.slate@nnec.on.ca. Connect with me through Facebook at bslate Wahsa. Remember, all of our lessons are up on bslate Wahsa for my YouTube channel under a playlist MBF3C. You can find everything there. Thank you so much for joining me today. I hope you have a lovely day. Miigwech.